All right. Okay. So, here's a problem that's important, but it's going to take a while. It's a little much going on. So, yeah, it is important though. So, we're trying to essentially show a way to calculate the midpoint of any segment in our coordinate plane using the two endpoints of those segments. So, let's just get right into it. We have some point A, which is x1 comma y1. We're not going to use specific numbers because it defeats the purpose of building a formula. We don't want to assume there are any specific values. So it's just x1 y1 for point A. Point B has the coordinate x2 y2. And then we got this point M, which is the coordinates x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. Basically, M is the average of the x values of the two endpoints and the y values of the two endpoints. And we want to show that point M is the midpoint. Well, if we think of like a line segment, right? You got line segment AB. If M truly is our midpoint, then that must mean that AM and MB have to be congruent. Because if they weren't congruent, if they didn't have equal distances, AM and MB, then M wouldn't be in the middle. So that's our goal. The goal, in essence, the goal is to show, that's what the heck. All right, the goal is to show AM is the same length as MB. And once you know, we just talked about a formula to calculate distance. The distance formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. So, using this formula, I can calculate the distance of AM, and then I can calculate the distance of MB. And if it turns out that they're the same, that's wonderful. It means that it basically means that they would have the same lengths, and if they have the same lengths, then M has to be in the middle. So let's start out by finding the distance of AM. Okay, so AM is equal to the square root. Now, it's a little weird. We have x2 minus x1, but you gotta remember, we're using the points A and M. So, like, my x2 is going to be like this one, and my y2 is going to be this one. And, well, whatever. It doesn't make, we'll get to B when we get to it, but for right now, think of like, the points in M, x2, and y2 in our distance formula. So just plug stuff in. We got x2 minus x1. So x2 is x1 plus x2 divided by 2 minus x1 and squared. I'm going to add that with y2, which is y1 plus y2 divided by 2 minus y1. A little weird conceptually, because remember, we're using points A and M. We're ignoring B, doesn't exist for now. We're just worrying about A and M. So I'm using only the points from A and the only point from M. And we get this mess, this horrific mess. So what can we do? Is there any possible way to simplify this? Well, I mean, let's think about what we have. So if I if we think of it as like like man, it's hard to explain, but think of it like this. Get a common denominator. You're adding a fraction with this whole number x1. So whenever you want to add like a fraction and a whole number, you want to establish that common denominator. In fact, I'm just going to show you how this is going to work. I'm not going to like write out a whole nother formula for it, but like right, I want to do x1 plus x2 divided by 2, and I want to subtract that with x1. But for me to be able to subtract, I need a common denominator. So to get that common denominator, I would have to rewrite x1 as such. 2x1 over 2. Because 2 over 2 cancels out, this is still just equal to x1, but now I have a common denominator. And I can, add this all up together. So I have x1 plus x2 minus 2x1 all over 2. And if we simplify that, well, x1 minus 2x1 is just, we have a negative x1 left over. So I can actually just rearrange this to x2 minus x1 over 2. So I'm going to do that right now. Like that. So this becomes, again, x2 minus x1 over 2. And squared, of course. And the same logic we can use for the y's. Just, imagine if I changed all the x's over on this right-hand side, the y's, and the same thing happens. So we get this. We get this part right here is going to simplify to y2 minus y1 over 2 squared. And that's pretty much as far as I'm going to take it for now. So now let's calculate out the distance of MB. So in order to do that, since MB is already like x2, y2, I'm going to do this. Now I'm going to change. So MB, right? MB is equal to the square root of, well, point B is your x2, y2. So I'm going to reassign that point M as my x1, y1. Because it doesn't really matter what subscript I use, x1, y1. It doesn't really matter. It just means like when I plug it into the distance formula, I know exactly where I'm plugging this stuff in. And since B is already given the names of x2 and y2, I might as well just redefine M as my x1 and y1. It won't make a difference, but you'll see. So we'll set up that same way as first. So we have x2 minus our x1, which, we redefined x1 as that first corner of M. So x1 plus x2 divided by 2, and then we're going to square that. And then add that with y2 minus, and again take the y coordinate from M, minus y1 plus y2 divided by 2. And then square that. Alright, we get something, very similar to before. And again, it's just the same logic. It really is. Like you want that common denominator so I can reduce this part. Well, to get a common denominator x2, you just write as 2x2 over 2 minus x1 plus x2 over 2. And, combine your fraction together. 2x2 minus x1 plus no, what am I missing? Minus x2 over 2. And that's just going to simplify to x2 minus x1 over 2. And the reason I did both negative, we have to distribute, distribute. Okay. Alright, so hopefully that makes some sense. And of course, the same thing's going to happen with the y values. So now we can redefine MB like this. Square root of x2 minus x1 over 2 squared plus y2 minus y1 over 2 and then squared. Okay, now let's compare our formulas for distance for MB and AM. Well, wouldn't you look at that? It's the exact same thing. This distance for MB turns out to be the exact same formula as the distance for AM, which concludes the fact that we have that AM is equal to MB. And because of that, that point M must be the midpoint. Has to be the midpoint. They're equally distant from each other. Okay. This isn't like 100% of the proof. Like, you would want to show that AM and MB have the same slopes too. Not just the same distances, but I'm too lazy for that. You can try it on your own. It's like the same idea. Plug in your midpoint value. Plug in the midpoint value into your slope formula. Your midpoint value over here. If you plug that into the slope formula, m equals y2 minus y1 over x2 minus x1, you'll get the same result. The slope of AM is equal to the slope of MB. I'm just way too lazy to do all that. This is enough. So I didn't want to make it any more than it had to be. But basically, using distance formula, you show AM and MB have equal lengths. And if they have equal lengths, and we'll just assume they have the same slope. Again, if you want to prove it on your own, you can. It's not super difficult. It's really a lot like this. Same slopes, same distance, so M must be the midpoint. So we get this nice midpoint. I don't know if you would call it a formula or not, since I guess it's a formula. But if you ever want to find the midpoint of a segment, of the endpoints, two endpoints, x1, y1, and x2, y2. If you ever want to find the point in the middle of those two, you take the average of the x values and then the average of the y values and make that your ordered pair. It's really simple in practice. Alright. Hope that was enough to understand. I know some of this algebra can get convoluted, and I know my handwriting doesn't make it any better, but hopefully you're able to follow along. If there's any part you got confused on, first thing you do is just like watch it on slow motion or something, half the speed, and like just try to follow along with all the steps I'm doing. But if you really want to, you can like leave me a comment or something, and I'll try to explain it a little better, because it is a lot of algebraic mumbo jumbo. But hopefully you got the basic gist of this and how you can see, all right, we can apply the distance formula to obtain new formulas and proofs that'll help us out later. So, all right, hope you enjoyed that one. Yeah, that's it for now. Take it easy.